Hey, folks.
Good day, everyone.
How's it going?
Good.
Uh, re- remind me who you're with and
Hey, hi Dan. I'm with NVIDIA, work with Jason Gunthorpe and
that's right. Okay, good. Yeah,
Rob.
glad to see you here. You're on the um GPU driver team or
I'm on the platform software team for our data
okay,
center platforms.
cool. Welcome.
Thank you.
And then also Cedric hasn't joined before. I know Cedric, but maybe other people don't know Cedric. You want to do a quick intro, Cedric?
Yeah, so I work in for Intel. I've been working on the TDX related stuff, generally speaking. So yeah, my focus is on the confidential computing and especially the application front of it. And then it's so kind to for me this meeting invite to meet you guys and trying to understand more about trusted IO. Yeah, thank you.
Okay, good deal. Yeah, thanks, and also welcome. This just other people that have joined before know this is pretty informal meeting. It's really just a chance to clarify kind of the conversations we're having on the list, and because sometimes things are lost in translation on mailing lists, but also so we can have some more high bandwidth conversations about some things. Um, mostly, mostly today is going to be opens and other people's questions. The only thing I really had on the agenda was just prompting for kind of a last call on that base PCI TSM series. So just the kind of the connect flow, that initial get the SPDM session up and running host side piece of the TSM driver. Um, uh, Alexi, you had the comment about can we please get rid of the ops back pointer thing? I mean, I was kind of okay with it. Middle option. You said you're okay with it. That's good enough for me. So that's two people. I will flip that around and get rid of the back pointer. And so it's one more spin. But I'd really like it to be the last one. So if anybody has any kind of pending, like it's like a speak now or forever hold your peace on that, and see if we can make V7 the last one. Does anybody need more time with V6? Maybe give it till the end of this week, and then I can spin a V7.
Uh, uh, do we need to solve the address association block things?
I think we.
Is it?
Well, okay. So, I mean, yes, we do. I don't know if I need to include it. I mean, I think it's 100% incremental, right? To what we have currently. So I would be okay if V7 keep leaving it out, but then we can use that as a baseline to do the address association. But it looks like previously I thought like, oh, hey, we can get away with it, and then it's like, oh, ARM needs it, but now also TDX needs it too. So it's really only AMD that doesn't need it, and so
Yeah.
Sorry.
Go ahead.
The only two patch I have against V6, which I'm carrying in my tree, is a small guest request change and address association block register helpers. Otherwise, I can run the full stack with V6.
okay, yeah, because the guest request change, I think I updated. Actually, that's another item for the that I want to put on the agenda. But I did fold in your guest request change. That's going to be
Where
included
the
in
okay.
the TSM code change that you added and making that one thing an in-out parameter.
Yeah,
Uh,
yeah,
Yep.
yeah.
Yep. So that's folded in. It's actually sitting on the TDX branch of that tree.
Okay.
And the reason, I mean, so I was gonna move it to the staging branch once I did V2. The reason that TDX branch is not part of the staging is a question I had for Alexi. But let's first finish the conversation about address association, because I think Loon, you took a look at Anisha's things and you had some proposed additional changes to it, right?
Yeah, about the address association.
Mm-hmm.
Yeah. Yeah, actually, yes, I think it could be in incremental, and we don't have to block the base PCI-TSM part. Yeah, so I see the patches you have, but I also see an idea from the NVIDIA people. Otto. Basically, his idea is that we can just query the direct connected downstream bridge of the DSM device to directly get the aggregated ranges that is for the IDE address association blocks.
So
And
will the non-secure like let us say there is an address range like MSIX table. Will that appear in that range when you query the downstream? See, the thing that I'm trying to do here is to kind of only put in address association block only those address that needs t equal to 1 TLPs, right? So we don't want MSIX, right? I mean CPU writes to the MSIS table to have t equal to 1, right?
No. We are not just establish the IDE encryption on this channel. If you we don't enable the T-bit if we don't transfer the VFs or any devices into TDSP run state. That means the IDE is enabled on all the devices of the endpoint, but the T-bit would not be enabled.
Yeah, I probably can check that if you have a patch somewhere. My only concern is will it be covering a larger range or like which we don't want it to cover kind of a thing.
Yes. The thing is that if you covered a wider range, then maybe some VF some devices may not being passed through to some secure guest, but the transfers are still encrypted by IDE. But I'm not sure that if you don't do it in advance, and then you just enable the one device for the endpoint, and you enable the IDE, then at the time when you want to pass through another function to
Okay,
some
got
guests,
that.
then what can you do? Yeah.
So
Yeah, yeah, what I ended up doing is I am doing the coalescing and the merging. So what you're instead trying to say is that don't even try to do that. Look at the downstream range and just add it to the association block because the number of blocks may be very less, right?
Yeah.
If I get that, yeah.
yeah, but yeah, and And just to repeat what maybe for Cedric, this is talking about the link encryption setup, and link encryption has this address association register that tell you, hey, when you're doing memory transfers, which transactions should be sent over IDE. But yeah, I think the question is, if we do this big large range and it includes insecure things like the shared MSIX, is that a problem? Because if the device knows it's not secure, and so it'll be a T equals 0 with IDE protected transfer.
Yeah, I don't know. I mean, for example, I am also right now I am also blindly looking at all the resources without even really consulting with interface report and things like that. And that's one question I had, like, can we send all the TLPs with the T equal to 1, or like, is there any holes that we need to create? Because creating holes is going to be very challenging because the number of address association block is very limited, right?
Yeah.
I think it's 3 that is mandatory, or 1 at some point, depending on which spec I'm looking on the ARM side.
Yeah, it seems very limited, and I would hope that it's forgiving. That like.
Yeah, probably.
Yeah. I can say that for TDX that if you route the mapping through the secure page table, then at last you add the T bit on the IDE stream, and if you go through the shared page table for the mapping, then you at last you will not enable the T bit on that IDE stream.
So that's how it works.
Yeah. Yes. So basically, you just don't add the we don't add the MSIX table regions into the secure page table. We add it in the shared page tables, and it will not append the T bit on the IDE stream.
Would you mind? Sorry, I'm new to this forum. But would you mind explaining the issue again once you guys are finished discussing?
Yeah.
You could summarize the issue that you're discussing. Sorry.
So when you're doing this IDE establishment, you're basically saying, hey, this endpoint wants to have a secure channel to this effectively root port or host bridge, and you have to program things at each end of that, and both of them want to know, like, hey, what are the allowed requester IDs that are supposed to be in the secure channel, and what are the address ranges of the memory cycles that should also be secured by this? Because
selective, or sorry to interrupt.
This is for selective IDE.
Okay.
There's also this concept of the default stream that says, like, hey, if the transaction doesn't match the requester IDs and it doesn't match any of the address ranges, should you also just send it over IDE anyway as a default thing? And that's what AMD is using, and then having all the kind of selections about whether it's IDE protected or not being driven by I think something on the IRMU side. But on ARM and Intel, we are needing the root port address association registers for the stream to say, hey, this stream for talking this endpoint is associated with these addresses. Now the problem is that what we're talking about whether it's too large or not, is that this big root port range covers everything downstream. So it covers not only the endpoint you're talking to, but it also covers every other kind of downstream device, and it may include address, like a device may have a sparse map of this bar is private, that bar is public because it's MSIX or some other use case, and the next bar is private. And so the concern is, what we're talking about is, hey, if we oversubscribe, or we over map the address range, what happens? Are we okay? Like, do we need to be fine grained about this? And and put holes
If we-
everywhere, or can we just cover big ranges?
If we map it, where are you talking about the selective ID registers, or do you mean in the I don't know. I'll speak in ARM parlance, right? So in the stage 2 tables of the realm, when you say
It-
map.
In this case, we're talking about the selective IDE control registers.
Okay.
But then when we talk about, but then Elu's talking about like, hey, how do we actually decide whether we actually set this t equals 1 bit, which is like in the IDE packet, is this a protected, must the device be in run state, must the if it's going downstream, and if it's upstream, is the memory protected? That t equals 1 bit is controlled by these stage 2 page tables. But the
Yeah, so the
actual whether it's
guidance-
IDE or not is just selective IDE registers.
Yeah, so the guidance we've used internally is, yeah, like you said, the selective ID registers has to map everything downstream of that port, right? And yeah, we do have 3 selective ID, the 3 address association registers. One for, I think, was that IO 32-bit and 64-bit, I believe, right? So so selective ID registers have to include everything downstream, and then setting of the TLP is based on whether your access is, again, ARM parlance, realm pass or non-secure pass, and then the root port's going to look at the incoming pass and then set the T bit according to that, right? If it's realm pass, it would set T equal to 1. If not, it would set it to T equal to 0.
Yeah.
So in that
Yeah.
sense, I don't think there's a problem with
So see,
oversubscription.
if the address association block is covering a non-secure bar, it's still okay for the device, is it? Like,
Yeah, the device would block it, right? So even if you, let's say you send a T equal to, let's say you send T equal to 0 request, let's say, it gets encrypted, it still goes to the device. The device will have enforcement on its side to drop T equal to 0 if it's attempting to access a protected resource.
no, I was telling the other way. One of the confusion I had was we now are going to program the association block with a large range, right? And I'm wondering if that large range has a small as a bar in between, which is non-secure, right? So it is now in the non-secure pass, right? Not in the realm pass. So T equal to 0 for MMIO, CPU MMIO writes, right? So we are getting a T equal to 0 packet at the root port, but the address association block is matching. So it will pick a stream ID and encrypt and do ID encryption and send it to the endpoint. Is that okay?
Yes, as far as we know, that's okay.
Okay. Then we are good. Yeah. Then we are good, I think.
But this proposal from Arto Yulun, I didn't see yet, but it sounds good. But you said it sounds like it could only apply if the physical function is directly attached. Because if we have if it's attached to a switch, and that switch is going to talk to non IDE devices, then we have a problem, right? Because then we'd be sending IDE to things. It would the IDE association would apply to ranges that are talking to endpoints that never establish IDE.
No, I don't think so, because we can only refer to the downstream port of the switch that can just connect it to the DSM device.
But if there's 2 switches, if it's not directly connected to the report, there could be a switch in the path. And now, but I guess actually we're
Switch is
okay
not
because there's not a
the
problem.
switch should be a pass through, right? It'll have ID flow through, and it should just go through it. It shouldn't care that it's encrypted.
No, I'm not worried about the device that we're connecting. I'm worried about the devices that we're not connecting. But I think the answer to my question, I just thought about it, is that we have address association, and we have the requester, the RID association. So like if we map the whole bridge range, and we have 2 devices behind it, one has ID established, the other does not have ID established, the root port would still not try to send IDE to the non-established device, because that device would not match any streams by the RID association.
I remember that the downstream port can only connect it to one endpoint. Is it?
No, that's for link ID.
Well, no,
right?
but the downstream port can connect. Yeah, for link ID, but for selective ID, the downstream port of the root port can connect to a switch. It can fan out all the way out to your one endpoint.
I'm not saying that we enlarge these protected ranges to the root port, the root port
Okay.
range. I just means that we just refer to the directed
Upstream port.
connected downstream port of the switch or the root port.
Oh, okay. That makes sense. That's even better. Yep. Sorry, I was thinking you said root port. Yeah, no, but yeah, the immediate next parent downstream port, we just grab its address range and forget about all the bars and everything. Just everything at that downstream port. That makes sense.
Yeah.
Okay. Yeah. So I think if we can do a V7, have that kind of be the last round of that base series, do the address association probably with the simplification, which sounds good. We can do that incrementally. Then we can put that to bed and focus on the guest interface and the guest requests and the.
Just a quick comment about this association on AMD.
Mhm.
We don't rely on default stream. We do rely on RMP table, where every RMP entry has IDE stream ID.
Mhm.
This is how we pick the stream and decide if it's T-bit or not.
But then why did I guess then I didn't quite understand the default when I took out the.
No, that thing is, I have to double check again. I forgot. I think it's for device.
Okay.
The device wants it, and it's like test device. So
Okay.
probably
So
not all devices want this.
okay. So we can let that be, like, we can let that default off, but let the solution we have now just stay, which is I'll let the low level TSM driver turn on default stream if it wants to.
Yep.
Okay.
Thanks for doing it. I'm happy.
Okay.
I only criticize. I never thank you.
See, this is what phone calls are for, because it's hard to get all the it's hard to
Right.
read. It's hard to read thanks on the mailing list. Like, is that an honest thanks or is that a sarcastic thanks? I can't tell. But on the phone calls, you can tell. Okay, but yeah. So, I mean, for the TSM dev change, does people know what we're talking about? Like, Alexi's pointing out that, like, he doesn't like the back pointers. I think we can get rid of them. I think it's okay.
Yeah, but
it's
I
okay.
mean, back pointers is rather like matter of taste. But what I specifically don't like about this TSM def and ops is that it's still a global, and we have, instead of one global, we have two global pointers to TSM def, and I want to get rid of globals. That's why I'm poking at this still.
Okay.
I gave up on backrefs of PDF because if
Okay.
I don't need it, I don't use them, and then I will send a patch to get rid of them if it's the case still.
But replacing ops with TSM dev, it's still going to be the case that you need that you don't know which, like, because yeah, well, maybe I'll post it. Like, you said it works, and if I can make it work, it looks clean enough to me. I'll just go with it.
You have a link, Alexi, of what change you are suggesting. Like, I think I kind of missed that.
Yeah, let me pull it up here if I can.
It's recent v6, and that is one patch we're discussing.
Okay, I can take a look.
Yeah, it is this one. I'll put the message ID in the chat, and you can go grab the link here. But yeah,
Yeah,
so that's supposed to be 1, 2, 3, not 1, 2, 2. But so the proposal is we're just going to go with that middle one, which is put the TSM dev in there instead of the ops. Maybe I'll share my screen. Okay, this is coming through.
Yes.
Okay,
Yeah.
so yeah, so right now we have this is struct PCI TSM. We have the ops pointer here. This ops pointer has an owner, and so for the ops that need a TSM dev, like the ones that set up the context like probe and lock, you have to you pass an ops owner. This proposal is we get rid of the ops, we get rid of the owner pointer, and you always look up the ops through TSM dev.
That will impact generic core. I don't think it will impact the architecture.
It will, yeah. It will. I think it only impacts the core.
Yeah.
I think you're right. I think it only affects the core. But yeah. But if other people have other things that they don't that this is going to bother them for the next 5 years in the core, let's get it changed now, and we can do it for V7. But try to do that by tomorrow if possible. I mean, early, maybe by next Wednesday, I'll cut a new version of that, and so just try to clean up any remaining stuff on V6. But I had this is a specific x86 thing. So ARM people, sorry for real quick, but this is, Alexi, one of the things that we saw as a cleanup opportunity on the Intel side is to always turn VMX on at the beginning of time, and as part of that, it looked like an additional cleanup could also be to always turn AMD SVM on at the beginning of time, and so the developer that did this work, he actually broke AMD because he's like, oh, I didn't have a way to test it. I didn't have a way to test it, so I didn't try to do it. And I said, no, that's not good. We need to, and Sean caught it too. We need to not break other people. I was wondering if you or somebody on the AMD side had a chance. I'm going to share my screen here again. Had a chance to test out this, or would have a chance to test out this patch. I'll put it in the link, but this is also on this TDX branch on tsm.git, and yeah, he's basically moving. Wait, is this the SVM one? Yeah, clean up, applying the same cleanup that we did on the VMX side to AMD, and this is kind of
how's this different from today? Like, I didn't look at this code precisely, so I'm not really sure. What is this all about?
The difference with this today is that virtualization would be enabled by core code and not by KVM. So it's basically getting KVM out of the CPU virtualization enabling business.
KVM now enables PSP stuff for virtualization. If you want just SVM, which is not encrypted, I don't think you need PSP at all. It should just work. But for SCV and SNP, then we need PSP, and that's delayed, and I don't think it's gonna move like any earlier that
Not
will be
gonna-
delayed until KVM asks for it.
Until KVM asks for it.
Oh, okay. Good. SEV firmware calls does not depends on VM this virtualization on, is it?
No, SVM needs to be enabled, but for SVM we don't need PSP assistance. Is my understanding.
Yeah, I mean, yeah. So like, I think this doesn't change anything on.
So if you're just enabling SVM,
yeah,
then it should just work. And if it doesn't, I'm curious what doesn't work.
Well,
so if
no,
you...
it's not that we don't know if it doesn't work. It's broken. It's that we don't have a way to test it. So we could go to Best Buy and buy an AMD machine, but but we don't have one.
We do have Intel machines just for this purpose.
Yeah, let me see if I can see.
No, I can give it a try and see if it breaks or not.
I mean that would the concern is like the reason why the other reason we don't quite trust just grabbing an AMD machine and trying it is like when we said, hey, we're going to turn off VMX, or we're going to turn VMX on all the time for Intel. Sean's like, well, hey, there's some other that might not be so simple because there's these legacy things you can't have it on all the time, and so I don't know if those same things exist on the AMD side. So this kind of yeah, testing is one thing, but another thing is asking like, is it okay for SVM to be on all the time?
Okay, I'll find out.
That would be super. That'd be super helpful because the reason it's in our way on the Intel side is because our PSP equivalent is behind a virtualization call. We have to jump into the SIEM mode to talk to our equivalent of a PSP. So TDS Connect, all this setup stuff, we need to do it with virtualization turned on because we're actually talking to this SIEM mode software, we call it, TDX module. Yeah, no, yeah. If you have time to try that out, that would just be super helpful. And yeah, so I'm trading you doing the TSM dev refactor for just checking out this branch. How about that?
Good. No,
Okay.
I've used these things as a learning exercise.
Okay.
To learn about this x86 business.
It's complicated, yeah. I don't, this call is recorded, but my career started doing Xscale validation, so I've always been more familiar with ARM than x86 my entire career. But
I'm from PowerPC. So.
Okay, so we're both refugees in an x86 land.
Yep.
Okay, so those those were the two big things I want to talk about, which was V7 and help on this SVM thing. What other opens do people want to talk about?
I had two items that I want to discuss. One is the flow with respect to guest. So when I want to unlock the device, the flow I was not so clear. From the point of view of the framework, we expect the driver to be unloaded and then you kind of unlock the device. The challenge with asking the driver to unload is it will clear the BME and that will move the device to error state, right? So I think we had some discussion around that with respect to what to do with MSC and BME config enablement, right? There was this point that VMM should emulate and then should not really do the actual BME or MSC. And like, it should be converted into DMA enable kind of like, DMA enable kind of like SME or like, RME calls and things like that. So that's one part I think I haven't got a clear idea about how this is going to look like, the workflow with respect to unlock. Do we expect the driver to be unloaded? And if so, is VMM going to emulate the BME, MSC?
Yeah, I mean, yeah, I've gone back and forth on this, but talking to Jason, like I'm really starting to warm up to the idea of when the device is in this lock state and the host knows that it's locked, then it knows that if the guest is asking for BME to be disabled and it hasn't asked for the device to be unlocked, then the host can know, like, oh, you are just trying to clear BME. I'm not going to do that because I'm going to wait until you actually unlock me, because that's so basically it's the host's job not to catch those error states, and
Okay.
and that seems the cleanest, because then we don't need like PCI core changes to try to intercept these things. It's all located nicely with the VFIO kind of device state. Like it's locked.
And the guest would expect the BME, like we don't, and the guest will, we are not going to return an error or anything. Like the guest will think it succeeded clearing BME. Right?
I think the guest should accept, yeah, that it cleared it, and the reason I think that's okay is that that I think we've seen in other cases where that the device is assumed to be idle if the driver is not attached, even if BME is enabled. And so, because otherwise, if we let the device go to the unlock state just for unbinding the driver, it makes it kind of complicated for, like, if you fully attested the device and you're in the attested state and you load the driver, unload the driver, you should still be fully attested. Like nothing has changed that should have affected the security state. And so the idea is that you don't need to go, if you do it once, you don't need to keep reattesting if you just all you're doing is unloading the driver.
I understand about the unloading part, but is the BME being used to do something else? Like, I don't want the device to now do like DMA anymore, kind of a thing.
Well, but like if you don't want the device to access the private memory anymore, then you unlock it, and that should also.
Will driver use BME as like an overloaded mechanism to do that? Like you just go clear the VME and the VME kind of ensures that there is no DMA traffic allowed from the device.
I know that. I mean, I know that's what some drivers do it like as a kind of safety measure, is like is clear BME, and we're also trying not to have to have the drivers be aware. Like they should be able to.
Okay.
They
Yeah.
should be like,
Because driver doesn't have the ability to unlock, right? It is user space. So I'm just kind of like, no.
Yeah, I mean, yeah. Driver only has the ability to mess up and trigger error state.
Yeah.
I mean, like, yeah. So I also think this is something that we might find out later. We might need to do more work, but at least the make it the host problem is
Okay.
it also is kind of a simple starting point.
Okay.
Oh,
So
again,
right now, what I will do is, sorry.
sorry, but if guest wants to clear BME, not doing so on host level, kind of yuck.
It's kind of
Really.
yuck, but that's kind of like, that's also kind of the if you want control of BME, then don't lock it.
And if we just clear BME as the guest asks, the problem is that device needs to be locked and accepted again. But
yeah.
it's a user space problem, it's a user space which is removing module and then not probing, right? So
Right,
the same script
yeah,
which does that can just do lock and accept.
Well, but can also do unlock if it wants to revalidate, right? You can if you want to keep the device attested, that will happen. Like you can unload, and you have to trust. You basically have to trust, because you're loading a trusted driver. So if you trust the driver to not do bad things, then you should also trust it to leave the device in an idle state when you unload it. And that's basically relying on that trust to say that's why it's okay to leave BME enabled. If you actually want, if the same script that's unloading the driver wants to guarantee that BME is disabled, then it can do the unlock, and that will also clear BME. I guess we need to make sure that happens on the host side. That if guest BME is cleared and we unlock, then we clear physical BME.
Yeah. So
Okay.
the other workflow interesting thing is, like, if we assume a normal unlock workflow, right? If you really look at the unlock workflow with the current patch set of patches, unload the driver, write tsmc route to the unlock file, right? So if you look from a device point of view, the device would transition to error state and to the unlock state, right? So which is not exactly what we want, and that's probably the reason why BME write should be ignored. Otherwise, we have to expect, because you cannot unlock the device with the driver loaded.
Right. Wait,
So we may want BME for
was that a question or is that a statement? Sorry.
No, I was saying I was answering Alexi, we may want to ignore BME for that reason, because if you don't ignore BME, the transition would be like TDI run, TDI error, TDI unlock, right? There is no other way. Did I make sense?
Yeah.
From the run state to unlock state, we will always transition to error state if you don't ignore BME, right? BME clear.
Yeah, that's true. Yeah, we would never be able to unlock without going through error state.
Error state, yeah. What about MSC? Like, is there
and going to error state is bad? How?
No, I'm not saying it's bad. I'm just saying if you go to error state.
Yeah. I mean, yeah. I guess there's a philosophy of crash-only software. Like the only way to exit software is to crash it. That's one design principle.
on the MSC side,
95% of how I stop QEMU is killing it.
Yeah, me too.
Barely ever shut down. So
yeah.
On the MSC side, I don't see the driver clearing MSC much. But then, is there a need for reprogramming the bar addresses? Because I think the when I would end up clearing the MSC is I will clear the MSC, then reprogram the bar address. Do we see a test scenario or a workflow in the secure device kind of a thing where I would end up clearing MSC, or do we need to do the same thing for MSC clearing too?
I mean, I'm assuming that it would be the same, like the PCI disabled device helper. It clears MSC too.
Yeah, but at that point I would have unlocked, right? I mean, that definitely we want. At that point, do we want the device to be in the locked state when the PCI?
I mean, toggling MSC after locked means we go to the error state, right? So that's another bit we want to manage. Like the BFIO says, no, you're locked. You didn't really mean that. I'm not going to.
What I was actually trying to poke there was MSC clearing. Is that something we should force the device to error state? Because the fact that we are clearing MSC means something is changing. And if a secure bar address is changing, I'm supposed to lock the device and validate the secure address again. So MSC clearing should take the device to error state.
Are there any flows with drivers outside of even typical drivers where we change the bar address while the driver's loaded?
I don't see that. And I see PCI Core doing the MSC clear. And one of the things I was reading was when a new device appear or some hot plug events would cause the bar address reprogramming by the OS. And what I'm trying to say is that if any such thing is happening, we want the TSM framework to reattest the new secure bar addresses, right? Which means I should force the device to unlock and follow the attestation flow again, where I look at the secure bar addresses and validate them on my range, isn't it?
Yes, but I would assume that only happens while the device is not attached to your driver. Otherwise, bad things would happen. So I'm hoping that Linux doesn't do that to a running device because things would crash, right? They would have to crash.
Yeah, which is fine. Let us assume that the driver is unloaded. Somebody's clearing the MSC from the guest. Should the host trap that and ignore that MSC clear if the device is locked? Is what I'm asking. I was thinking we should not.
I think if the device is locked, then you can't. Like, yeah, so driver's unloaded, device is locked. PCI core says, it says, hey, I can change bar addresses now.
We should force the device to error state, is it?
Well, but the host has no idea that they can't tell a difference, right?
No. See, if that happens, then your device goes to error state. So before you load module, while thinking it's in trusted mode, what device is in config lock state or run state, you should always check what's the actual state.
Yeah.
Although, yeah.
But I'm assuming that writing the bar addresses would also have to take the device in the error state, right?
It will, yes.
So I think you're okay. So yeah, we don't have to. We can still.
Okay.
We can still
ignore the MSC, but the bar update will take the device to error.
The bar, yeah. So you'll if you expected the device to still stay in lock state, you'll notice like, hey, my device is actually in error state. Oh, it's because PCI
Okay. Got that. Yeah, I can do that. And that was the two workflow question I had to get the full stack. I did have another question with respect to the user space interface for attestation. Like, did we? I mean, last time we did conclude about some tooling that NVIDIA is using. We should make the things work with that, or there are some generic attestation workflow out there. Because if you are trying to get guest patches, finalized without looking at how we are exposing the measurement blocks or the certificate chain, the guest workflow is still not complete, right? So I was looking for pointers regarding where I can get more details about this. So, I mean, what are we doing there? Like what, I know we don't want to look at it right now because we are looking at the other interfaces, but there is also this desire to kind of have some clarity on what will the interface look like, or if there is any pointers. I think last time we discussed about some attestation framework. Is there an open source attestation framework which I can look at to see what it expects?
I mean, the last time I saw something was this TDM thing, and that TDM thing looks like it's gone defunct.
So it depends on what you mean by an open source framework, right? Are you talking about an open source verifier? Are you talking about patches for pulling the measurements for the kernel? What exactly are you?
Yeah, I think what we need is a sample verifier to understand what the kernel should expose, right? I think at this point, what is not clear is what is the expectation of the verifier, right? At least one verifier, if we can take a look, then at least we can see, okay, this is what a verifier typically expects, and this is what the kernel should return to the verifier, right?
ARM has
or in other,
yeah. So there is an open source verifier that the IETF uses as the example for everything that they put out standard wise. So that's Verizon, I think is how you say it. VERAISON. And recently in the attestation SIG, a couple of people from that group that worked for Oracle published presented on a daemon that they've published called RATSD. And the idea is it would act as an evidence gathering agent on the system. And they currently have a TDX, and I think they said maybe an SCV plugin to allow them to pull the measurements of the confidential VM, but they don't have anything for the devices yet because there's no kernel API for it yet. So you could look at that and see what they're doing for the I guess the regular guest measurements and go from there and see what formats they're expecting things in. But the reality is the formats, I imagine, different based on what your CVM technology is.
But for the kernel, why do you care about the format? I mean, I think you just need
No,
to
I mean, yes, exactly. So I think what is still not clear is I think there was this discussion that it cannot be sysfs. It has to be netlink. If so, is it going to be a specific measurement block? Is it going to be all the measurement blocks? Or are they expecting the full transcript with signature, right? So I think we are talking about getting the guest patches table and getting it merged. But I'm wondering, all this thing is not useful unless we have a way to show the measurement details in the guest, right? I mean, imagine a guest kernel where none of the measurement information is available to the verifier.
I mean, like, so the reason I'm pushing, well, focusing on everything but the attestation is because that is actually useful to some people. That that one, you can test hardware, you can test, like, you can finally start actually testing devices at scale if you have that stuff, and you can do verification by other means. I mean, so it's but I mean, I do agree that, yeah, people are gonna, the whole point of this is to immediately get to the full attestation flow. But I think you have something usable. I think you have something usable when you have IDE. I think you have something usable when you actually get the device to a lock state, and then you have even more functionality
Yeah,
when you can
definitely, yeah.
attest it. But yeah, I think in terms of the interface, like, so yeah, Alexi has everything in sysfs. We have Lucas that started sysfs for the native SPDM stuff, and then people said, no, if you want transcripts and nonces and these different things, go netlink. What's really been missing is somebody to just keep iterating with the community on that. So
yeah, so there has not been an RFC patch for that netlink, right? I don't see one.
Yeah, I mean,
posted, right?
so Lucas has unposted patches in his tree that do some netlink things for the native
Okay.
case. The native case, but I think somebody would either need to look at that and be like, oh, okay, what additional stuff do we need for the TSM case, or just use that as inspiration to the TSM thing. But I don't think we should wait for Lucas to circle back to that. I think we this is kind of an open call to the community. Like, if somebody has time and space to start pushing on this, like, I think it's kind of a up for grabs task at this point to do things and yeah. I mean, we also have plumbers coming up, and maybe the plumbers, everybody can kind of sit around and look at what Alexi has for, because
one quick comment. So aren't the interface and the format of the measurements, they're orthogonal? Like, even the interface is allowing fetching of all the measurements, but the format of the measurements wouldn't be like vendor specific, and it's something defined in something like RMM spec for ARM architecture. So is that not enough?
Well, like, what I don't think any of these things are vendor specific, right? Like, this is the SPDM transcript. This is the measure, the device measurements. Like, I mean, the actual blobs inside of the measurements may be device formatted, but it's still kind of device measurements, interface report, and transcript, right? These are all.
Yeah, the SPDM part is common, but RMM spec does mention like there is a way to extend the platform token with the device measurements. So that becomes like vendor specific when device measurements are also like embedded into the platform token, CCA platform token that contains realm token as well. Like, they all of them together, and device measurements also would be bound with the platform with some of the public key information or a nonce kind of stuff. I mean, if we get device measurements individually, then how do we say that they belong to that platform, or like how do you, they're fresh, or how do we make without having some kind of binding there?
So that's part of what that RATSD daemon that they're putting together is supposed to do, because you're supposed to be able to pass a request for a nonce measurement to all the various things on the platform, and then wrap them up together into an actual platform measurement from individual device measurements.
Yeah, exactly.
So, yeah. So there's a lot of work in this space being done in other areas. Whether a month back there was talk of using the it was talked by a lady from Microsoft Azure about using the virtual TPM for binding device measurements to platform measurements using some technology there. But yeah, like you said, there's definitely a lot of open questions on how do you bind all of this into an actual attestation token that someone can use and actually send to a verifier. But that's kind of independent of getting the information out of the kernel, because the reality is most of the attestation stuff is driven from user space. The kernel is just there to provide evidence to be gathered. Even in a sense, the accept flow is also driven from user space, right? So, like Dan said, there's a perfectly valid use case here for having something else in user space that just writes to that accept sysfs node for the device and says, I'm willing to accept the device now, even though I may not have the extent of measurements I want for it. So I think getting all the attestation stuff in place is kind of an entire effort in and of itself, independent of all the other work going on for this. And
Yeah, I
it
agree.
spans a whole bunch of different working groups to do it, whether they be confidential compute consortium working groups, the IETF, all sorts of various people.
Before we run out of time, like I just want to ask a quick question. Like, sorry, I joined a late. I don't know if it is a repetition of the question. So Dan, your V6 PCI core infrastructure patches. I did see what the write-up you have, but you mentioned about 2 vendor implementations will make those patches get merged. So my question is like, do we want like do you want to see the patches posted in the upstream, or is it like I see some kind of different interpretations? Like some people are saying as long as we have a ARM version of it and other vendor version of it in GitHub, that's good enough. Or some people are saying no, that's not enough. Like we have to post the patches, the minimal patches that are required. So which one is right?
I want to see the patches, and I'd like to kind of similar to what Yulun kind of put together for TDX. Like we just did like here's the core infrastructure, here's the vendor code for it, and then for that piece, and we can leave all the IMM PFD stuff, the DMA buff, leave that for later. We can even probably leave the guest side alone just to get these first 2 vendor implementations on the host side core done. But yeah, I mean, so like vendor trees are okay to kind of spin things, but like I think we want to get to a point where it's like, hey, we have at least two vendors, but it looks ready to have three vendors ready to go in a tree with patches that people are happy for them to be there.
So the patches in a tree and posted in the community.
Yeah.
Yeah. Okay.
Yeah, on the ARM side, what I've been doing is to kind of like clean this up in such a way that the guest side patches are all collected together in the beginning of the patch series, because the hypervisor changes are still not like, there is IOMMFD bits are kind of like, we still need to kind of get that reviewed, right? So one of the things I have been doing on the ARM side is to kind of, when the V6 posted, I had a kernel tree done on the GitLab ARM, which was kind of like collecting all the V6 patches followed by the ARM patches, right? The reason I avoided posting that is because I wanted to move to an alpha 16 version of the spec, because
as long as like ARM has a plan to update them like based on alpha 16 spec and post the minimal patches required. I mean that works.
But why does it matter? Why does it matter, Anish, whether it's 12 or 16?
Also, the reason is that the guest thing completely changes from an RSI to RHI, and that kind of messes up with the entire patch series, right? So I'm in the process of writing the alpha 16, and then, so there is so much of churn around even in the guest patches that I'm writing, right? So alpha 12 is a very clean, nice implementation that I have, which I have actually posted. But the moment we switch to RHI, things get changed quite a lot on the guest patches. So even if I post something, it cannot be merged into any tree because the entire thing is getting rewritten again, right?
Yeah, I mean, I was gonna ask real quick, like, but can you do the host side connect stuff separately? Just that seems pretty simple. Or
The
disconnect.
connects the connect stuff alone can be done,
Okay.
but just to get the IDE flow figured out, right? Yes, definitely. But I have kind of clubbed that as a part of the host side along with IOMMEFD. So if you look at my patch series, guest followed by IOMMEFD, followed by the connect, followed by the rest of the things, right? So I was.
So I think,
so,
But yeah, but we shouldn't club everything like IOMM, UFD stuff and all. Like we should just need the minimal patches on top of the V6 patches to show that
to achieve what? Minimal patches to achieve what? To achieve IDEs
dance patches
setup?
can get merged.
Yeah, to achieve merging the core, and maybe like I was talking about Yulun, like it's not nothing. Like I think, I mean, it depends if your platform allows routing T equals 0 traffic over ID, but like you could actually use that on 3 different architectures to establish IDE and have secure links.
Oh yeah, definitely. So
Yeah.
if we want only patches to establish IDE, we can do that. But the thing is that for me, in order to test these things fully, right, I need the full stack.
Oh yeah,
So
I mean, but that's what your tree is for, and that's okay to have GitHub Git trees for that.
okay.
Like I'm not saying don't do that, but I'm just saying like, hey, to help to get the consensus stuff over the goal line, it's probably going to be missing features, but it's going to be simple and it's going to support the base, and I mean, and it'll be something we can build on.
Yeah. Also, NVIDIA can help with enabling the IDE and testing the T equal to 0 traffic.
Okay.
Yeah.
Okay. So maybe what I can do is, so what you're essentially saying is there are 3 kind of like topic branches. One is the guest topic branch, one is the IDE setup branch, another is the full-fledged accept workflow, right? So I can create 3 topic branches, and these 3 topic branches can be independently posted is what we are concluding, right?
Yeah, that kind of the
Yeah, I can get that going. Yeah.
Host connect's ready to go first, and yeah, but I mean, I think we immediately want to get to the guest side because I think like that's very important for people to be able to actually have kernels and distributions that can do the guest side. So we want to do that immediately after getting the connect side done. But yeah, let's just get IDE out of the way so we can put it to bed and focus on the guest side.
Sure.
And Dan, just I'm going to go through the patches more thoroughly in the next few days. I'm sorry if it's late. I can let you guys go and I'll ask over email. Just 1 minute if possible.
Okay.
There's no link. You're only focusing on selective ID, right? There's no link ID support, but the framework is in good shape to be extended to link ID without too much.
It could be extended to link, but we're also like, who wants link? I think it needs a kind of a justification.
Okay, I think we want link.
I keep hearing about people wanting link, but they also say they don't want host OS to deal with it. They will do like link IDE via some back channels. From DMC, from PSP, avoid host OS.
Yeah. So okay. We can probably take that next week or offline. But yeah, I think saying that we have interest in link ID and potentially extending the TSM framework to also support link ID. Not necessary that the host has to do everything, but that's one possibility. The other is doing it via the TSM also, right?
Okay. Yeah.
Which will require us to look at the interfaces of establishing connect, right?
Yeah.
I mean, we are now saying there need to be a way to select whether I want a stream ID or a link ID, then connect.
It's a step function increase in complexity, and it's like, yeah, I'd really want like from a Linux perspective, not just from like my own personal working perspective, like from a Linux perspective, why should Linux care about link IDE? Is I think that needs to be.
Yeah, we plan to use it. We've got use cases, but yeah, I suppose we can discuss that more next time, I think.
Okay. But Well, yeah, good discussion. I always start these things off as being like, oh, I only have 2 agenda items, but then like we get a good critical mass here and have good discussion. So yeah, I appreciate everybody joining, especially the people that are not on the other side of the planet who need to go need to go eat dinner now and put kids to bed. But for everybody else, yeah, have a good rest of your day, and we'll see you at the next one.
Yeah, thanks.
Yeah,
Thanks.
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 Yeah. Bye.
Bye.
Thanks. Bye.